Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 just asks, what is an exergonic reaction? Okay, so an exergonic reaction this is a chemical reaction where the energy is exiting and a way to remember that energy is exiting is because exergonic and exiting, they both start with EX. So that's a way that you can remember that energy is exiting in an exergonic reaction. And it is exiting the system. Exergonic reactions are also known as spontaneous. So spontaneous reactions mean that they occur without the addition of energy. So we know that a reaction is spontaneous when its Gibbs free energy value, so when delta G, is negative. When delta G is negative, this means that our reactants have more free energy than our products. Okay, so these are some of the characteristics of an exergonic reaction, and we can also draw a graph of energy versus time to show the reaction and how much energy is produced or released as the time of the reaction goes through. So typically, an exergonic reaction graph kind of looks like this. So here is where we start off, our reactants, and they have a higher energy than our products. And then we can show delta G. Right here. Delta G, and it is less than 0. So that means that it is negative. And we can also say that energy was removed. So you can see our reactants are at a much higher energy than our products. And this is the characteristics of an exergonic reaction. So now let's see the opposite of an exergonic reaction, which is an endergonic reaction. So endergonic reaction, again, it is a chemical reaction. But this time, energy is added. Energy must be added before our reaction can proceed. Okay, so an endergonic reaction is known as non-spontaneous. And that's because it doesn't just occur because we need energy in order for it to occur. And also, for endergonic reactions, our delta G value is positive. So this means our reactants have less free energy than our products. Okay, so now let's compare an endergonic's reaction diagram. So again, we're going to plot energy versus the time. And the energy of our reactants starts off low. And then as the energy progresses, our products have a higher energy. So this is our reactants. This is our products. And again, we can show delta G. And this time delta G is positive. So delta G is greater than 0. And energy is added. Okay, so these are the definitions for both exergonic and endergonic reactions. So the junior tutor said that an exergonic reaction is a type of chemical reaction wherein energy is released. This means that the change in free energy is negative and that the reaction is spontaneous at the right conditions. Yep, so this solution is correct.